Hello, let's talk about physics in this module. We've looked at wiring things up, we've talked animations, game objects, kind of bring things into our Unity scene, but how does the physical world interact with each other? So that's what I hope to cover a little bit in here. The game engines inside of Unity, we have two of them. We have, for 3D, NVIDIA PhysX, which is a really, really neat physics engine, and it's used by a bunch of folks. So Unity, Unreal Engine 4, and it can literally support hundreds of objects that have physics on them inside of a scene. For the 2D physics, we're using kamx3pnl, which is also a common third-party physics engine, also used by Unity, GameMaker, Construct2, other well-known engines as well. 2D is generally much faster because you don't have an additional plane that brings out an extra layer of complexity. Integrating with physics from a high level is actually pretty easy. Typically, you have two components on a game object. First, you have a collider. And a collider simply tells you what region you're going to detect collisions on. Whether it's going to be a box, or typically in like a first-person shooter, a humanoid shape would have a capsule on them. That's also the reason why you see sometimes like an arm or an elbow disappear behind a wall, because it doesn't have a collider on it. Only the center object of mass on that humanoid shape has a collider. The second component that you need, depending on what you want to do, is a rigid body. And a rigid body gives mass, and it really allows that object to be under the influence of gravity. If you want a fixed platform in space, it just needs a collider. If you want an object that's going to be moving through space and hitting other objects, you should have a rigid body and a collider. If you have just a rigid body, the object will fall, but it will never hit anything. So again, the rigid body is used for mass, that gives it mass under the influence of gravity. A collider tells what that object looks like to the physics engine. Remember, a 3D model is just a collection of points in space. That is not what the object looks like to a physics system. It's what you tell it looks like. I can take a ball and tell the physics engine it looks like a box this big, and it's going to act just like a box. I can take a car and give it a sphere collider, and the physics engine thinks it's a sphere and will roll it down a hill. So it's all about what the actual collider looks like, not what the object physically looks like. And then lastly, there's this obscure concept when you first learn it, after a while it becomes second nature, called a trigger. And a trigger is used for essentially collisions that shouldn't be using the physics engine. Now, why would you do something like that? Think of a common case where you're running along in a game and your character runs over coins. Do you want a moment in time where those coins stop your player and you make him stutter? No, you want that player to smoothly move over those coins and pick them up. And a trigger is used for region detection. It's a type of collider with a little checkbox that says it's a trigger. It removes it from the physics simulation that's going on in your scene, but still can respond to let you know when something has come within its region. Another way that you would use a trigger is, let's say you're a zombie, and you are only supposed to come to life when somebody comes within 10 meters of you. You have a big sphere collider around you, check off this trigger, and when something comes within that space, your code will get notified and your zombie will come to life. And we'll look at that inside of the demos here. Now, adding physics to game objects here, I have a little screenshot of this floating cube in space. It has a box collider on it. Basically says, all right, yes, this object looks like a box, but according to the physics engine, it's a box of this size, 1, 1, 1, 1 meter, 1 meter, 1 meter. In this one here, I turn off the mesh renderer, so it becomes an invisible box, just to show you the collision region. Notice this green outline shows you what it looks like to the physics engine. This could be a sphere, it could be a car, doesn't matter. We try to use pretty basic shapes when we're dealing with physics. If we have a car, we use a box collider that we kind of make a long rectangle. If we have a zombie or a human or a humanoid shape, we use a capsule collider. We don't worry about things like fingers. You know, you could in a game, but it's a lot more difficult, which is typically why like a shot to an arm of a character doesn't really do anything, but a shot to the center point does, because you have a collider in the center of that object. Again, as I mentioned, also the reason why you see things disappear behind other objects. If a part of an object doesn't have a collider, it will just pass through another object. You see that all the time in games. And that's done for performance reasons. We want simple colliders on objects. All right, let's look at basically doing some physics and coding on physics here. So in this Vamp Kid versus Zombie Apocalypse, let's take a couple different scenarios. Now, I've got this key here and a coin. Let's assume that we want this key to fall. Let's just click play to start. Let's see what happens here. Let me hide my UI because we don't need it anymore. Now, let's assume this is going to fall. In order to fall, all I need to do on this key is add a component. Let's actually start from scratch here. Let's remove this component. In order to fall, I'm going to add a rigid body. Now, there's two types. One is for 2D, one is for 3D. I'm dealing with 2D here. I'm going to add a rigid body 2D. Now, I'm going to click on pause and play. This allows me to do a frame by frame by frame advance. Now, let me go frame by frame by frame. Now, notice I'm falling with gravity. I'm picking up speed. I hit the bottom of the ground, nothing happens. Why doesn't it happen? I only have a rigid body. I don't have a collider. It has mass, but it doesn't know where to collide anything with it. Let me move this up a little bit more. It'll probably fall pretty fast here. Yeah, so gravity is a fast beast. So that's why I paused it, went through frame by frame. Let's move this guy down a little bit. Now let's change this, and let's add the second component required here, a box collider 2D. Now, when I add that, that gives me something of a more physical bound that we can have on this object. You can see when I go to the box collider here, this green square, that is what it looks like to the physics engine now. So if something hits this upper corner here where there is no image, it's going to treat it like basically it got hit. So it's acting just like a box here. When I click on play, immediately this object is going to go underneath, under the power of the physics simulation here. So let's go ahead and click pause. Actually, I'll play this because I should hit the ground and stop. Okay, now the zombie's going to hit this object. Let's go over here and see what happens. He's pushing it along. Why is the zombie pushing it along? Well, the zombie has mass. The zombie has a rigid body, has a mass of 1. This object has a rigid body with a mass of 1. So my zombie can push this guy out of the way pretty easily. If I make my key have a mass of like 1,000, and now I play it, it's a trap. It's going to fall. That zombie hits it. It's trying to push it out of the way. It just doesn't have the force. It just stops in its tracks. Now, if I want to turn off, notice there's no checkbox here. If I want to turn off physics for the object, and there's different reasons you do this. Maybe you just want to disable physics until it's time to bring this object to life. There's is kinematic. And that essentially removes it from the physics simulation as well. This object is still active. It's just not colliding with anything. It's not acting like it's an alive physics object. And there's different reasons to do this. Maybe you want to move the object on your own as opposed to using the physics simulation, the physics engine, and you can do that. That's one of the more fringe use cases for is kinematic. For the case I'm doing right now, it's just to essentially disable physics. So it's just going to float there in the sky. Next, let's go ahead and talk about this coin. With this coin, this has a circle collider 2D, which makes sense. It's what shape is this coin? It's a circle. Now you can edit these colliders. You can make them bigger. So this collider is kind of small. If I want it big, I can do that. I'm going to make it about that big. But now notice this is called isTrigger. So anything will pass through this particular object. So if I click on play, and if I move over to the right here, notice I pass right through that object, which is kind of expected. I essentially don't want that coin to stop me, but I want to, quote, pick it up. I want to do something with that coin. Now, we need to write code in order to do something here. So let's add some code to both of these objects here. Let's do create a C# script, and we'll call this key physics. And we'll create a C# script, and we'll call this coin physics. I want to call out the difference. The only two differences between these objects, I can even turn this back off now. As it stands right now, the only two differences between these objects are one has a box collider, one has a circle collider. And this circle collider has is trigger checked, which means it's going to pull it out of the physics simulation. Again, this is because I want it to notify me in code when the vampire runs over it, but I don't want it to stop the vampire. This one, I'll be notified in code when it hits something. It's still going to stop the zombie because this is a full heavy object right now. It's got a mass of 1,000. Let's go and open up our key physics first. It asks us to reload our project, so we just added 2 new projects, so it uniquely regenerates our Visual Studio solution for us. And I actually don't need any of that basic code there. This is just template code that they give you to start. But first, let's actually, even before we delete that, let's go ahead and add our other method. I did Control-Shift-M. I want to say on collision, and you'll notice we have on collision enter and enter 2D. We have to get the 2D versus not 2D, which is 3D. We have to get those correct. We're going to do on collision enter 2D, and on collision exit 2D, and on collision stay 2D, just to show you what these methods do. I can delete my start and update. And I'll just do a debug.log collided with collision, the object that we got passed in. Collision.gameObject. If we look at all our properties here, of course we want name. But just to show you, we get that nice IntelliSense. And I'll just paste this in here and just change my debug message. Just paste in the actual method name. Enter happens when they touch. Stay happens each physics frame that we're still touching. And exit happens when we leave our collision. All right, save that. And let's go back to Unity. It's going to compile our code. Click on play. And then we're going to keep an eye on our console window to see what happens here. Let's collapse our messages. All right, now the problem is we didn't take our code and assign it to anything. So we need to take our key physics and assign it to our key. And take our coin physics and assign it to our coin. And then let's double check it, make sure our code is there. All right, perfect. Click on play. Okay. Key physics collided with our base ground. We've now collided with zombie. We're now staying with the zombie. Let's clear that. Let's pick up our key. We can go over here and do it. Now we've exited collision with the zombie, and there we go. Now we're essentially on collision, stay with zombie again. And now we've just called on collision exit 2D with zombie because our zombie has now moved out of the way. So those are the code methods to talk about when collisions happen. Now we could destroy something here. If we destroy, let's say when we hit our zombie, destroy. And we'll say collision. We don't want to destroy our collision object. We want to destroy the game object that it's associated with. Destroy the object that we just hit. That's what that one line of code does. Very common in Unity. Destroy a game object. Let's make sure this falls on our zombie, shall we? Right, maybe like here. As soon as we start, it's going to happen fast. Let's keep an eye out. Oops, that didn't happen. What did we hit first here? Did I not save this? Helps if I actually save it. We saw that it actually looked like it smushed the zombie down. There we go. Not only did it just take out my zombie, but it took out that level of ground that it hit too. So it destroyed anything in its path. Very simple to destroy objects. The other thing that we can do smartly, we could say if collision.gameObject.tag is equal to zombie, then and only then should we destroy it. That makes sure that we only destroy our zombies. If the tag of what we just hit is zombie, destroy our zombie. Let's make sure that we spelled it right because it is case sensitive. And it is lowercase z is our tag. Let's go ahead and just make sure we change it back to a lowercase z. Save our changes. Play it. And we should only be destroying that zombie because we're asking for the tag of what we hit, and if it's zombie, destroy it. There we go. Perfect. That's how we can filter out game objects. Now lastly, let's look at our coin. Open up our coin physics, because coin is slightly different. Instead of on collision enter, we use on trigger enter. And it works the same way. I'm only going to do enter, but exit and stay would work the exact same way. We're going to do on trigger enter 2D. Can delete our other methods here. Debug.log triggered by, in other words, who just came within our region. Let's write out the name of who just triggered us, and then we will destroy our game object. Now, we don't want to use this. We don't want to say destroy this, because this actually refers to the coin physics class. We don't want to destroy this. We want to destroy the entire game object. So destroy game object. Let's come back over here. Click on play. Keep an eye on our console window. Move our zombie, our vamp kit over this way. As soon as we hit this coin, there we go. Our coin disappears. Easy enough. That's all the code we need to detect that. Now again, we need a rigid body and a collider. In order to have collisions, one of the objects must have a rigid body, and they both need a collider. Very important. They both need colliders. At least one of them needs a rigid body because it has to be moving. Alrighty. So now we destroyed a game object here. Essentially, we should increment some sort of score, but we don't have a score yet to increment. And that will bring us to our next module where we're going to talk about UI. So now, hopefully that gave you a pretty good idea of the basics of physics. We can integrate. We use a rigid body. We use a collider. It could be a box collider, circle collider, and there's a whole other set of the colliders used for 3D as well. Don't mix the two. We have a rigid body 2D component, which gives us, hey, look at that guy. We have a rigid body 2D component, which gives our object mass and automatically acts under the influence of gravity. So you add that component, you add your collider, boom, you have physics. You can write 1 or 2 lines of code to integrate with that physics. It's very, very easy and a very common use case to do exactly what I showed you here today. And you'll see that in the workshop as well. Next, we'll talk about UI, and I'll see you then.